Yes, we are live now.
Okay. So everything is fine. Maybe Hidoi can also check once if it is fine.
Yeah,
If I don't share the full screen, it is difficult, is it?
It's fine, sir. Yeah, maybe that's okay, I think. So from let's see in YouTube how it is coming, sir. I think it should be fine.
No, let me see if I stop sharing and go to this and then share this windows. Yeah. Now you see this, okay?
Yes, yes.
Now can you, but I can't update this. That's my problem.
You go to the second slide.
I don't know how to do that.
Oh.
In fact, if that can be done, there is nothing like that.
So directly you can click to second slide, maybe.
I'm trying.
Oh, it's not happening, sir.
Sir, from the taskbar.
No, wait, one second. Okay, I don't know.
Yeah, it is coming now.
No, this is coming, but I can't see you. That is okay. See, let us not worry too much about this. I think let us go ahead with this.
Okay. So you can shift to second slide, I think. So
now, every time I have to change the slide, I'll go back and change it and so on. Okay?
Okay, sir.
Just one trial. You see, now I can see all of you. If I want to change the slide, I will do this. Now I can again go back to this. Can you see that?
Yes.
Is that all right?
Yes.
So let us struggle like this a little bit. It should be okay, I think.
Okay, sir. Okay.
Let us not too much worry about logistics, because in this whole thing, content will be lost otherwise.
Yes, sir. Okay. So now we have Sir Priyanku Sharma sir also. Sir, you know him. Priyanku sir.
Yeah.
Okay.
Priyanko. Good evening.
Sorry, good evening, sir.
Nice to see you.
Yes, sir. How are you, sir?
Fine, doing fine.
Yes, sir.
Okay. Sir, we are live now in YouTube. Maybe we can start.
Okay, good.
Okay. So, briefly, sir, what is the plan? Initially, I'll introduce you and I'll give a brief overview of what we are going to talk. And then you can start your talk. And then at the last part of our session, once you're complete, then we can take the questions. So whatever will come in the YouTube chat and whatever we got from the Google Form, whatever we shared. So then, sir, I'll get started. So hello, everyone. After a long pause, we are going to start our Assam AI initiative lecture series. In this first talk, we are inviting Professor Yegnanarayana from IIT Hyderabad. Currently, he is as an emeritus professor and INSA honorary scientist at the IIT Hyderabad. And Sir is going to talk about what are the different challenges in processing natural signals like speech. So this will be a very insightful and interesting session to attend. So before the talk, I'll just give a word. I'll talk about because everyone knows Yegnanarayana sir, and but just to introduce her, I'll just go do a brief overview of that. So, sir is currently as a emeritus professor and INSA honorary scientist at the International Institute of Information Technology, Hyderabad. He was professor emeritus at BITS-Pilani Hyderabad campus during 2016. He was an institute professor from 2012 to 2016, and professor and Microsoft chair from 2006 to 2012 at IIIT Hyderabad. He was a professor and head of CSE department at IIT Madras, and a visiting associate professor at CMU Petersburg in USA, and a member of faculty at the Indian Institute of Science, Bangalore. He received BSc from Andhra University in 1961, BE, ME, and PhD from IISc Bangalore in 1964, 1966, and 1974, respectively. His research interests are in signal processing, speech, image processing, and neural networks. He has published over more than 230 papers in the different aspects of speech signal processing. And he is author of a book, well-known book called Artificial Neural Network, and by published PHI India. He has supervised around 39 PhD students and 42 MS theses at IISc, IIT Madras, and IIIT Hyderabad. He is a fellow of the Indian National Academy of Engineering, a fellow of Indian National Science Academy, a fellow of Indian Academy of Sciences, and fellow of IIIT, and a fellow of International Speech Communication Association. He was the recipient of third IETE Professor SPC Aya Memorial Award in 1996. He received the Professor S.N. Mitra Memorial Award for the year 2006 from INA. He was awarded the 2013 Distinguished Alumnus Award from IISc Bangalore. He was awarded the Syed Hussain Jahir Medal from INSA. He received Professor Raiz Ahmed Memorial Lecture Award from the Acoustical Society of India in 2016. And he is also Life Fellow of IIT Kharagpur. He was Associate Editor of IEEE Transaction on Audio, Speech, and Language Processing during 2003 to 2006. And currently he is associate with Journal of Acoustical Society of America as Associate Editor. He received Doctor of Science from Jawaharlal Nehru Technological University. Currently, he is also he was also the visiting professor at IIT Dharwad and CMU Africa, Rwanda during 2019, and also he is distinguished professor at IIT Hyderabad and adjunct faculty at IIT Tirupati. So, so we can see like this is a vast experience sir has and different aspects. And now I think sir, you can start the session.
Okay.
Maybe you can take the questions in the test.
Okay, thank you very much for the kind and long introduction. But good evening. I hope my audio is clear. At any point of time, I would request the organizers to interrupt me and tell me my audio is not clear. Okay. And since I'm not very familiar with this Google Meet and so on, there may be a little difficulty in switching from PowerPoint to this and so on, switching the slides, but I think you should bear with that. You please focus on the content of the message I'm going to speak rather than on the slides and so on. Okay? And any of you want, I will pass on the slides, copy of the slides at the end of the talk to the organizers. You can have access to them, so you don't have to take down any points or notes from the slides. You will have a copy of that after my talk. Okay, good evening again. And when the organizers asked me to give a talk, first thing I got a doubt was, who am I addressing to, kind of a thing. You see, if whether the audience are specialists, experts, faculty, or research scholars, or simply BTech students, or and what background, computer science, electrical, I don't know any of what is the background of this audience and so on. So with that in mind, I don't know at what topic and what level of presentation will be of interest to majority of the people. But whatever it is, now that we are here, so what I'm going to talk in the next 1 hour, probably 45 minutes to 1 hour, is to subject I know a little bit, that is the speech signal processing, but not really speech signal processing per se, but it is the challenges in processing the signals like speech. And most important, why is it that it is a challenge to process, and why do we need to do processing? I want to take a couple of minutes to give a little background to this. And these days, if people don't talk about AI, neural networks or something like that, they think that you don't belong to this modern society. But the fact of the matter is that although I don't implement any of the current systems, I do keep track of what is going on here. And I want to begin with the for the first few minutes, the what is kind of everybody is after kind of a thing, the so-called large language models and chat GPTs and things like that. Although I have not used them, but I know what they're doing, and they're obviously doing not only great things, but they're also doing great harm. You see, and more important is that we seem to miss the key points in that. Let me just start with a very common term all of us use, what is called the NLP, natural language processing. I will please bear with me. I will just switch this slide and then come back to this. I'll just give a little background to natural language processing. And all of us use this word natural language processing. And the LLMs are supposed to be doing natural language processing and things like that. Be careful. First thing is that word natural. What is natural there? And second thing is, I'll tell you there's nothing natural. Strictly speaking, the way the so-called large language models are doing, there's nothing natural there. And surprisingly, there's no language also. Of course, with Priyanko among the audience, I'm a little embarrassed to say this, sitting in front of an authority like that. But the fact of the matter is that language in a colloquial use is very different from the language that is typed in the form of a text and so on. So in that sense, the natural, why there is no naturalness, I will tell you. And why it is not even a language, I will tell you why. And we are processing that. That is the point, you see. And then let me come back to this. You see, after all, any language, when you talk about a language, it is mutually understood signs and symbols and conventions and so on. And it is mostly in spoken form, apart from, in addition to a lot of gestures. And that you have both vocal gestures, other gestures, hand gestures, and so on and so forth. You see, all these form the communication between individuals. You see, and these are mutually understood units or symbols or something like that. That is the language. You see, in fact, when I visited Assam a decade ago, several times, of course, and I heard Professor Priyanko's talk several times, and I was amazed to see how communication takes place with so many dialects and so on. And there's no such thing as one single language there. You see, that is true everywhere. I'm not talking about only Northeast or something. Everywhere it's like that. But that is communication. Communication still takes place in the spoken form. There is nothing like a language means it is linked with the text. Text has nothing to do with language. You see, language means it is a spoken form only. And that spoken form that we have, thanks to the technology, what we are doing here is we are converting that into a text form. That is a speech recognition and so on. This is where the first damage is done. All the naturalness that you feel or experience when I'm talking to you, or when you are talking, somebody is talking to you, is lost the moment you put it in a text form. That means, and next what happens? And that text form, when you type here, thanks again to Microsoft Word and other gadgets that we have, it starts editing that and removing all the grammatical mistakes and so on. After all, no speech, whatever I am speaking now, nothing is grammatical there. But you see, but that is natural. But all that is lost in the text that is typed and processed by this one, and including a lot of corrections. In fact, even if you intended to say something, the correction won't allow you to say have that typed. You see, so they will type it and bring it in a form beautifully grammatical, syntactically correct everything form of a text, and that is the text that we are trying to process. So notice in this whole process the naturalness, very naturalness. The naturalness in the communication now in the spoken form when I am talking to you is not only in the speech sounds and the language, in fact, the and gestures and so on, all of these. It is not just one mode. It is a multimodal phenomenon. In fact, that is why you can see you will always learn when the speaker is in front of you. You want to see his movements and his gestures and things like that. All that naturalness is not lost in the text, and even in the normal casual mistakes or your style of making mistakes, all that is lost in the processing. And finally, that nice text is what you are processing in LLMs, you see, and that's exactly what is happening, you see, and that is where you bring all the constraints to LLM and so on. So that is not natural language processing anyway. And you can see, and also when you do that, many applications they say, I can tell you all that is nice in a commercial sense and so on in office setups or company setups, but they're just not useful in a person to person communication, in a casual communication that you encounter in daily life and so on. So the technology can never be used. Everybody talks about machine translation, speech translation and so on. All that is, will not work because all the naturalness is destroyed there, you see. So to be more specific, what is destroyed is the so-called multimodal features in the communication, in the spoken form of communication that you have is lost in the naturalness. So, and then what happens is after processing, we try to reintroduce this to bring naturalness. That's what they say. At all, what you are capturing, the multimodal nature of the communication when I am speaking, is not learned by rules or something. It is all acquired, and not only that, it keeps changing from point to point. Now I am talking to you. It is not that I practice talking like this to you. You see, so it is all very naturally coming in. So that cannot be modeled. So if you cannot model, but at the same time it is so natural to enjoy, to appreciate and enjoy and get the message. So then, but somehow these NLP guys want to put that naturalness back into that by modeling the speech or modeling the dialogue and things like that. Dialogue cannot model, unfortunately. You see, this is the main problem in NLP and so on. And this is the main problem, that same naturalness now. Next step, what we will see is we will go to the speech part of it. And so the speech part of it, you see. So in the speech part now, now let us see the convert to the speech, come to the speech part of it, you see. So as I told you, it is whether you like it or not, speech is the most natural mode of communication, and it is a natural mode with all the additional gestures, vocal gestures, external hand gestures, and so on and so forth. There are many other gestures that form part of the message and so on. And it is the most natural. In fact, the best thing that you can see importance of speech is if you ask somebody not to speak for some time, he will go mad, you see, because it is impossible to keep quiet. So natural mode of communication, and there is no explicit language information. For us, all of us think that language means some text or something like that, that is script. That is where the wrong notions are being spread out, you see. Language has nothing to do with script at all. See, we start writing Telugu script or Devanagari script or something, that we say it is Hindi language or Telugu language. No, I can write Devanagari also in Telugu script or even in Roman script and so on. So text has nothing to do with language. You see, somehow we got confused with all of this, and so in the speech part of it, we want to, lot of times, if you want to handle this natural speech, you want to use some kind of a simplification by what is called to understand. You see, if it is person to person communication, there is no problem. But if you want to extract certain information and use it for some other purpose, you need to model. And modeling what? Modeling the production part of it, speech, or the modeling the production means articulatory movements and so on, or modeling the sounds it produces, or modeling the prosody, for example, or the prosody, I mean the intonation and duration, and which we don't know how to model, because we never learned prosody by rules, and we can never learn also. And and then of course modeling the language I'm using while speaking and so on, and modeling emotion. How do you model emotion? See, for example, and dialect is the most misused word in this world, especially in our country. See, because when I heard again Professor Priyanko's talk sometime, I think Northeast has several dozens and maybe even hundreds of dialects and so on. There's nothing like a dialect, and you can quantify and say there are 10 dialects, 20 dialects. So dialect is most abused word here. And then dialogue. Dialogue also is not. All these are model. The moment you try to model, you lost. You lost. You see, and you can't say that you can model and incorporate them back into the message or something like that. And but why do you need to model some of these things? Because maybe in some specific applications like synthesis, for example, you want to just hear this speech mode, what is there in the text form in a machine. That is okay. You don't have to worry about all these other additional features. Or you want to recognize uh, uh, speech and the form and put it in the form of a text or something like that. Then also you need to model. Or you want to recognize the speaker, who is speaking, kind of a thing. And of course, very important thing is that if you have a large amount of audio data recorded, and in that you want to know where is certain person spoke in that audio file, or what is the word corresponding to certain audio region and things like that, and so on. And also you need to model again to or understand. When I say model, enhancement, because most of the time we communicate in the speech mode in a very practical casual environment where the environment is noisy, and so the speech you speak also is not really very precisely articulated and things like that. You need enhancement and so on. So these are the places where you try to model some aspects of speech, but none of them make a complete modeling or capturing the information in speech and so on. And I already mentioned the NLP, that is already speech to text and then text processing and so on, removing all naturalness and so on. And most important thing in speech is I want you to understand the distinction between speech processing and speech signal processing. Very, very important to understand. A lot of us, use these words very casually. When I am speaking to you directly now, or in a classroom, for example, and when you are listening to that, right now also when you are listening to me with my video on, you are doing speech processing. You are doing speech processing. What do you mean by that? You are getting this audio signal, speech signal, and so on, and then you are processing and getting the message out of it. You see? And while doing that, you use implicitly lot of knowledge that you have acquired over a period of time. You can't even articulate. You know English language, you know that it is some talk related to speech or speech signal or something related to AI and things like that. All that background you have, and you tend to use that in understanding what I am speaking and so on. So that is speech processing by a human being. That is what happens in one-to-one. As opposed to that, if you capture the speech through a microphone and store it as a file, audio file, that becomes a speech signal, and you process the speech signal. See, human being processing the speech is called speech processing. A machine processing the speech signal, you can see, I just a minute ago what I mentioned was when you process, you use a lot of other knowledge without your knowledge, of course, inadvertently. And then you process it to get the message. You are interested only in a message. Oh, this person said something, or this person said is emotional while saying this, or something is very emphatic in while saying these things like that, you see, or is very casual in saying all this information we capture, you see, and in a speech processing. In speech signal processing, machine cannot do any of this because it has only signal as the input. It doesn't have all the other knowledge and so on. It is this that caught the attention of people around 70s, you see, around 70s, and then try to see not only speech signal, but can you bring in somehow this knowledge which we seem to use it effortlessly to make this speech signal processing a little more similar to what we are doing and so on. That is what, that is about the background to speech. So the important thing that we to understand here is, in the background to speech, difference between speech processing and speech signal processing. And another very important thing I would like to highlight is the following. When you are processing the speech, for example, when you are listening to man, you will not listen to all the sounds. You will not be able to focus on all the sounds. And you will select a few sounds depending on your background and so on, and then make up the message. You see, that is how this is called a selective attention mechanism of human being. This is true with the text reading also, but I don't want to switch the topic. I just want to say that in speech processing by human being, we do selective attention, and everybody talks about AI and so on. That is the I part of a human being. The I part of a human being is the selective attention mechanism, which nobody knows how to do it, to implement it in a machine, because we ourselves are not able to articulate and say this is how I am doing and so on. It is if you happen to listen to all the sounds I utter, for example, then you will not get the message at all. You see? And that is the beauty of the selective attention mechanism and so on in speech processing. And in speech signal processing, unfortunately, you don't have the luxury of those traditional knowledge sources as well as this selective attention mechanism and so on. And now let us move to the we went from natural NLP to background to speech processing, and now we talked about speech signal processing. Because since I don't know the background of many of the audience, I am assuming that most of them are not very familiar, although they might have heard about it and did some processing, may not be very familiar with the characteristic of the speech signals. And it is very important to understand speech is a natural signal. And what do you mean by a natural signal as opposed to a synthetic signal? The natural phenomena everywhere. And let us focus only on the speech case. Speech is a natural signal. The characteristic of a natural signal is that signal can never be repeated second time in life. It's very interesting. You see? Even a simple sound like ah, you put it a microphone and speak in front of a microphone and record it. And you keep saying ah for the rest of your life, and you can never match that signal exactly. But the message is captured. That is the beauty of naturalness. Any natural phenomena can never be repeated. If it is repeated, it is not natural and it is useless. You see, fundamental principle. In fact, it's a place, especially I don't have time to delve into the AI applications and so on. Maybe toward the end, if time permits, or if I can link up to some of these. So basically, my idea of this presentation also is to motivate people to say that they not that AI related thing, the technology advancement is said that all the problems are solved. Coming to think of it, if you hear lectures like this, you know that nothing has been solved. Nothing has been solved, and people are unnecessarily misdirecting us, to giving an impression that whole world is all problems are solved and so on and so forth. Nothing is solved, and all the technology that is currently there is likely to lose its importance, and something else will come. You see? So anyway, characteristic of natural signals. You see, this slide alone, on single slide, it will take about 1 or 2 hours. I will finish in 1 or 2 minutes. But the most important characteristic of the natural signal is that it is never repeated. And that is where, in order to mathematically characterize this, we invoke the concept of random process. I'm not going to the details of that, but the random process is not random. Please always note that. We are getting confused here. Random process is very crisp mathematical theory. You see, very clear. So speech production is something like a random process where the output is got a sample function, can never get repeated, but message is repeated. You see, and another very interesting feature of speech here is when I said that, okay, when I am talking and some of you are very good at taking notes or something or dictation like thing, you will notice that when you take that dictation, as I already mentioned to you, you will not hear every sound. And even if some sounds are missing, you will substitute it and so on. That is what the message part of it. That means if I have to really speak a few sentences and I ask you to take down, and all of you may get the same text, but the way you do it will be different. You see, and so that is the so random. And another very interesting lot of this requires a little more explanation in signal processing, which I don't want to do it. But the when you are saying that I spoke this sequence of sounds, notice that there are no boundaries for these sounds. You have to artificially introduce the boundary. Not if I give the same speech signal to several people and ask them to mark the boundaries of different sound, no two people will come up with the same because there are no boundaries. There are simply no boundaries. I don't have time to explain the speech signal is has the sounds have indefinite duration. Indefinite duration, that means there's no fixed duration here. You see, but still you get the message. If you want to understand briefly, although it's not exactly similar, if you have a cursive script, for example, and you try to segment it and recognize character, you can see that most of the time you can't segment. Even if you segment, you can't identify the character and so on and so forth. So these are some of the things, and so this is the characteristic of a speech signal and speech production. It is natural. These are the characteristic of a natural signal. Why I am highlighting this point is this is the one that is missed in the technology completely. And people are not that they are not aware of that. They just want to skirt it. And by just cutting it, the problem doesn't go away at all. You see, please note that. And also, beautiful thing when you are listening to me, for example, in speech form, speech, the processing you do is not with the same time frequency resolution. I don't want to elaborate on this, but the signal processing concept, the time frequency resolution of the sounds that I utter, you dynamically change depending on the need and depending on your background. So it is not a fixed one. And also, I don't want to confuse you with this, but I want to use one word here. Just as I mentioned, selective attention is an attribute of intelligence. You see, this human brain, or the way we listen to speech or listen to music or listen to whatever it is or see a video or whatever it is, we do what is called the our biological network, neural network. What it does is dynamically reconfigurable architecture. I don't want to elaborate on that because that requires about 1 or 2 hours of discussion. But it is not a fixed architecture. It's it is a dynamically reconfigurable architecture, which you reconfigure when you listen to my speech continuously. Same thing when you listen to music or something, or when you see a video or something like that. And we don't know how to do that. You see, and that is where the technology cannot do that because we don't know how to do it, to implement it. You see, and so this is the idea. And of course, there are several other things I want to skip here, and and most important thing again, the speech part is apart from this all these characteristics, selective attention, and so on. It will help you to handle, and a lot of redundancy, of course, redundancy, context, and everything plays a big role in speech communication, and the effect of environment, and effect of channel. Channel means the telephone channel or whatever it is, or multi-speaker environment, like the so-called cocktail party effect, most abused word, of course, because nobody explains what it is and so on. So these are some of the effects that you have, and you think that you collect the speech in that environment and process it and get a good speech. Sorry, the answer is no. In such an environment, you can't even produce good speech. If you happen to extract the actual speech signal that you produce in that environment, most likely it sounds awful. You see, because you cannot produce a clean speech just as you produce in a clean environment when you are in a practical environment like this. You see, somehow we have even signal processing people are also confused us with this, saying that in this mixed signal we can separate this and so on and answer. You can't separate. Even if you separate, it is dangerous, because that separated signal is what you have spoken, but that is not clearly articulated speech. You just spoke a few sounds, or even conveying a few event which others capture, rather than producing a clean, neat speech and so on and so forth. So the environment doesn't affect the speech signal that is produced, affect the production of the speech itself. That is what is important to understand. This is unfortunately again not taken into account in the current technology. Same thing, of course, in a room also, when you speak about there is what called the reflex reverberation and so on, and so they want to de-reverberate. No, your way of speaking in a practical room, if you are able to extract that the direct speech part without reverberation, it may not sound good. You see, so please note that these are all factors that make the speech signal processing a challenge. But for a speech processing by human being, there's no problem at all. You see, in fact, many of you may not know this. Since I am also a person worked in acoustics long back, about 40 years ago, and in fact, you need that reverberation, slight reverberation, what is called the acoustic warmth. That means that liveness. In fact, if you don't have that reverberation, you feel the sound is awful. It said, you see, that is called a dead room. And if there is a reverberation, it is a live room. But processing reverberation by human being, no problem at all. But by a machine, it is horrible. It's impossible to do it. You see? So these are some of the characteristics of the natural signals like speech and so on. You see? Now, what I propose to do, I will skip a little more technical details are coming, but I will skip. Just project them and skip. Okay, this is speech production mechanism. I'm not going to details of that. And I how it's produced, you see, with this vocal fold vibration, it's remarkable. You see, although some variations are given here in the excitation, in fact, that excitation is exciting the vocal tract system and producing speech. We can perceive it, but it is extremely difficult to process it by a signal processing method and so on. And it's very interesting, and there are many languages have these. For example, glottal stop is a legal sound in some African language. I don't know. I may be wrong in my articulating this, but I think Ethiopian language there is what's called Amharic or something like that. They use glottal sound stop as a legal sound and so on, but we don't know how to process it. You see, and so these are some of the things. Anyway, one can each slide a project is strictly speaking half a semester course. You see, so that is the and then of course I don't. I again want to skip this, but I projected this for one simple reason. You see, when you talk about this a speech signal, those of you who are not familiar with speech signals and so on, don't worry too much about it, because I just want to highlight one important part in speech production. This is simply a waveform for a utterance called mask, MASK, but put in two lines here, otherwise they are single line only. roughly 1 second of duration and so on. What is the important thing I want to highlight here is this gap between S and K. There is a silence, you see. Mark, this is called a silence, and you say, oh, it is silence, why can't I remove it and save, remove some samples and so? No. So silence also carries meaning, so that's why there is sounds of silence. In speech, there is sounds of silence, and you have to retain them. And if you remove them, you would have changed the sound itself. So again, my point I want to make here is the challenge in handling the speech signals and so on. And of course, this is just a spectrogram waveform and a spectrogram. I am not going to details of this. This is more of a signal processing. What I want to highlight here, this is slightly technical, but please bear with me. And I think because we are talking about challenges in speech signal processing, the tools and techniques that we are using, digital signal processing tools, and even if you are not familiar with that, don't worry about it. They are highly limited. They are not developed for speech signals, and we are using them. And in using them, obviously you have to pay a price, and the price you are paying is not a small price; it's a large price. And so, of course, that requires a little bit of understanding, but I would like to mainly mention what is called a short-time Fourier transform, because speech is a time-varying vocal tract system excited by time-varying excitation. So the system itself is changing with the time. So you have to take short windows of speech, short time, and then process it by ending the Fourier transform spectrum and so on. So this is what is normally done in all speech processing, but unfortunately, even that itself is very crude, so crude that most of the information is lost. But still, you may say, "Oh, how this professor doesn't know that we are still processing and getting a beautiful speech recognition." Yes, that is because of the tremendous amount of redundancy that is there, not because you have processed it correctly. You see, and so the short-time Fourier transform. And there are 3-4 broad categories of short-time Fourier transform analysis, which is very popular and in all the systems implementation. You see, and most of them use what is called the short-time Fourier transform magnitude or the spectrum. And because any Fourier transform of a real signal has both magnitude and phase part of it, phase part is ignored. And it is ignored for several reasons. One is, you may say ignored. Most of the times the reason they give is, oh, phase is like a sour grapes kind of a thing. It has no information and so on. No, that is not true. It has fantastic amount of information, but you can't process it. You can't handle the phase signal in a signal processing way, because I don't want to go into details of that, because what is called the phase wrapping. The phase computation, there's no mathematical way of computing the phase using a MATLAB computation like a tan inverse imaginary part by image, real part and so on. You see? Because phase is a real function from extending from minus infinity to plus infinity. It is because of that phase cannot be handled. Since you can't handle, it becomes a sour grape. They say it doesn't have any information from that is wrong. You see, so in the DSP tools that we have, we use the Fourier transform, short-time Fourier transform magnitude, but phase is ignored. And likewise, there is what's called a capsule analysis. That means we talk speech as a excitation of a time-varying vocal tract system with a time-varying excitation. So we have source and system, both are convolved, kind of a thing, convolved. So that way, to deconvolution, it performed in a transform domain, and that is how you approximately try to separate source and system characteristic. That is called capsule analysis. Don't worry if you don't follow some of these technical details. For the sake of continuity and completeness, I am using this. And capsule analysis is popular, and even today it is used in many, but only the magnitude part of it, or real part of it. The phase part also is impossible to compute. That's why they don't use it at all. And again, they use the word sour grapes. It has no information, which is not true. And then there is a third way of popular way of signal processing, DSP tool for speech processing, is called linear prediction analysis. That means it is a model based speech processing, which will enable you to model the vocal tract as an all-pole model and so on to extract the resonances, and the remaining part is called the residual, which mostly corresponds to excitation and so on. But in all of the model is okay, resonance are okay, but the residual looks noisy, although it is not completely noisy. But it has more information. But again, since you don't know how to process it, you call it again. It's like a sword graph. Linear prediction residual is ignored. Although if you listen to that, you can make out who the speaker is. You see, and sometimes even the message. And the fourth part here is most of the time in speech signal processing, we use what is called, block processing. That block is typically a segment. A segment is of the size 10 to 30 milliseconds or something. So that segment you use and try to compute the estimate the spectrum and so on. That is what you do, and that is called a segmental analysis. Segmental analysis is the one that is most popular. All the commercial systems, including the current deep neural network system, most of them, everybody uses this, segmental analysis and so on. But the beauty of that is of the speech is lot of information is there in 1 or 2 millisecond duration. And the moment you take 10-20 milliseconds, that is averaged out and gone. But we don't know how to do this subsegmental analysis. Or lot of information is there in a suprasegmental. That means if you take 100 or 200 milliseconds segments and so on, you can say that is where you get the idea of a duration of a sound unit and the prosody or the intonation. And that information also is gone. So most people use segmental analysis, and suprasegmental and subsegmental analysis are ignored because you don't know how to handle it. So these are the problems with the DSP tools and technique that we have. And this is why, since the title of my talk is Challenges in Processing, Speech Signal Processing, this is the problem that we have with the current DSP tool. And a lot of work need to be done, and not by just tinkering a few MATLAB commands or codes or something like that. You have to think originally how to do it, because human beings are able to do all of this by their biological neural network, although they can't articulate it, as I told you, and with a time varying resolution, time frequency resolution. But machine or algorithmically, we don't know how to do it. And of course, it's all skirting the problem, just saying, oh, it is not important and so on. That is where the problem comes. It is not important because you don't know how to do it, not because it is unimportant. So, you see, and so this is so these are the speech signal processing, and these are the techniques. And of course, this particular slide I would I mentioned to you, if you want to process the speech signal in a machine and get to the units, sound units, and then from there words and so on, sound unit. For a want of a better name, I use the word phoneme, or you can also use the word syllable, and so on and so forth, word and things like that. So you want to get a text out of it and so on. That for that you need to produce this analog signal that you have, which is a continuous function of time and amplitude. You have to produce as a sequence of discrete units. That, for want of a better name, I call it as a symbol. Signal to symbol transformation is the first step in machine processing of a speech signal, and we don't know how to do it. And the choice of symbol, choice of how to process it and get it is, of course, varies individual depending on the purpose and so on and so forth. And most of them are very crude. In fact, even today, if you ask me, the only problem all of us have to solve, both as a linguist, as a signal processing person, as an AI person, is how to extract represent the speech that is produced with all its information that is there at the various levels in the form of a symbol. For want of a better name, I call it a phonetic engine, for example. And if you can do that, you don't have to do anything else. Somebody can use it and make billions of dollars. And of course, in the process, you will make billions of dollars in the first place. You see, that how to capture what is produced in a symbolic form is a challenge. It's probably the biggest challenge. In fact, this was the problem I was thinking, and in fact, I was given to address 50 years ago when I was visiting US and so on. Even after 50 years, it still remains as a problem. You see, and So I don't want to go into details of this, but otherwise you can't do any processing in the machine at all. You see. And sorry for skipping the many details of this, but that is in the time that I have. And let us come to discussion of some of the uh, uh, specific things that have happened with the limited knowledge of speech signal and speech signal processing method. And even in 1950 years ago, they built a automatic isolated word speech recognition system. You see, that is called using dynamic time warping and a template matching and so on. You see, that is the isolated word. In fact, Tom Martin and they started a company for voice data entry through voice and so on. But of course, very soon you have to wind up because it doesn't work in practical environments and so on and so forth. And so then what that is simply a template matching is that no knowledge of speech is used and so on. But then in 70s again, lot of people, especially Carnegie Mellon, Stanford, and so on, they realize, especially CMU, realize that when human being, when you process speech, you use lot of knowledge. When a machine, if you are wanted to process, you have to bring in that knowledge somehow. It is that knowledge-driven methods is what was discussed and very popular. Many practical speech systems were built, limited vocabulary, of course, in 70s, using that knowledge-driven search methods and so on. In fact, if any of you have any interest, you can refer to a book. Now it may not be available. I know. Trends in Speech Recognition book by Vian Lee and Jane Chu, published in 1980, indicating the importance of knowledge in processing speech. Just as that is what I said, distinction between speech processing by human being and speech signal processing by machine. And what we do as a human being, somehow you want to bring some elements of that by bringing this knowledge and so on, prosody knowledge, acoustic phonetic knowledge and so on. This trends in speech recognition, although it is 50 years old now, but it is an excellent book. I think it's worth reading, keeping it and reading the book. You see, although it may not be available, but you should understand the effort that goes on and also what we are not doing. And then slowly the computing power is increasing and AI business coming, expert systems came in early 1980s. That is why the rule-based methods have developed for speech processing and so on. And even that had its own limitations because bringing rules to process speech has become very difficult and so on. So it lasted only for about 5 years, and suddenly it was given up in preference to what are called the statistical methods. Statistical methods became very popular around mid 80s, and by the end of 1980, thanks to Kai-Fu Lee and others, they have produced a continuous speech recognizer, which all of you know what is called the swing system, where it is based on the large amount of data training and produce using the language constraints and so on. That is the beginning of the statistical method, using lot of data for for producing the phonemes and distribution of the phonemes and the words and so on, language model constraints of the word syllable, phonemes, syllables, words, and so on. The statistical methods, the most important mathematical model in the statistical model is what called the hidden Markov model. Hidden Markov model, and that was very popular in 1980s and so on. Probably it was rated as the best computer science research in a decade of 80s. You see, that is and so and then what happened is around towards later part of 80s and 80s, neural network, artificial neural network models started coming, and then the emphasis got shifted, not shifted probably, but slightly more emphasis was given to neural network model for speech recognition and so on. But very quickly, that both statistical models still exist because the data-driven methods have come. The computing power is increasing in 90s, late 90s and so on. lot of data you can collect from various microphones and other things, and lot of storage, lot of computing power. So everything is kept aside. Now it is called the machine learning. Machine learning simply means that you collect large amount of data, let machines worry about the distribution, and distributions are supposed to capture the meaning or whatever it is context. That is the idea. This is the development of speech recognition systems. And of course now this is about 90s and 2000 to 2010 first decade, and later 2010 onwards, you know more than me, it is all so-called deep learning and things like that. I don't want to go into that, but you know, and now it is all data driven. You need not in the this interesting. Just when I was at the Institute of Science 45, 50 years ago, and my research scholar, we all worked with 1 second of speech. 1 second of speech, and we produced about 15, 20 papers. And quite a few of them are IEEE papers. Now I have 100 hours of speech, I can't even write one paper. You see, now it is all you need 100 hours, 1,000 hours, and so on. If you write a paper with 10 hours, they say no, it is not accepted, and reviewers will reject it. So it is unfortunate, and they skirted the importance of speech and went into numbers game. That is what has happened. And now I will the next slide will show you. Okay. I don't want to go into details of this, but what is important here in the statistical approach, even today these terms are used, Gaussian mixture models, which is nothing but a clustering, a sophisticated version of distribution of each cluster is called a Gaussian mixture models and so on, used extensively for speaker recognition, and in speech recognition, the first step to get phonemes and so on and so forth. And then, of course, hidden Markov model, Gaussian mixture models, which are used for, they don't use the sequence information. Hidden Markov model, they use not only large amount of data training and so on, but they also use the sequence information, Markov model. Anytime you hear the word Markov, it means sequence. You are having a sequence knowledge, and sequence contents are captured there and so on. And then, of course, the last one, all of you know better than me, so-called deep neural network. And you know, they say it does a lot of things, but anyway, I have my own reservations on that. And in any case, even if it does, we don't know how it does it. Okay? So now, but if you don't talk about deep neural network, you know, they think that you are not, you don't belong to the civilized society or something like that. You see, but unfortunately, the term itself is wrongly used or misused. But I don't want to go into those details and so on. You see, why I am mentioning this is, it is not that everything is solved and so on. The challenges and the limitations of this will let us think, do we need that much of data? Do we need that kind of a computation and so on to do that? After all, when you are listening to me now for the first time, most of you, have you ever asked, did you say that I have to listen to my voice for about a few minutes before you start understanding what I'm speaking? You can see that is the human way of doing it. You don't need to large amount of, in fact, if you have a large amount of data, you will not be able to learn it all. You see, so but unfortunately now it is all data driven. 5 or 10 hours, 100 hours, 1,000 hours, they think it is too small. And so that is how the commercial, you know, everybody wants to sell their Nvidia wants to sell its GPUs, and Microsoft and Google wants to sell their products and so on using this. But the fact of the matter, the way human being does these things are, it's very different, and it doesn't require that kind of a computing power and that kind of a data as well. And so I don't want to go into details of this, but at the same time, I just want to mention this. Some system, specific system, where that is currently built and say, oh, I have a speech enhancement. What they are doing is they are trying to model the degradation instead of enhancing the speech. So it can take up to some point and then not beyond. You see, whatever is missing in the final output, you substitute from your brain. That's why you think it is great and so on, but nothing is great. Enhancement is a challenging problem. And speaker recognition, as I told you, Gaussian mixture models are used, and the temporal information. If you are able to, tomorrow, if you don't see my face, but if you still hear my recorded voice somewhere, oh, you will say this is the guy who spoke on that day and so on. That is because you are able to capture the temporal information of the so-called prosody and duration and intonation, which the GMM model based models don't capture and so on. And speech recognition, of course, the HMM, DMM, everything required large amount of data and so on. And speech synthesis also got into this machine learning mode and so on, started, but I think that is where we are being misled into it. Speech synthesis is the most challenging problem, because in recognition, you remove the information to get the text or message. In synthesis, you have to insert it. You have to insert all the relevant sounds and natural variations and so on, naturalness, which you don't even know what it is to introduce and so on. Speech synthesis is an absolute challenging problem, and that is when you are supposed to have understood. But of course, we know that we don't understand. But everybody says, I get a better, because the synthesis output that is produced, the missing 90% of it, you are substituting while listening and so on. So this is about the next. Now let us come to, I'll complete in another 5 minutes, practical issues in speech processing. And some of the things are, I have listed a few, but there are many other things. First thing that we should understand is speech and language. The speech, although you attribute a language, speech doesn't have a text at all. You see, spoken form is very different, although language simply means it's mutually understood symbols or units, rather than it is a text symbols and so on. And then this is very important, ill-formed sentences, and it is a natural dialogue. You notice that when I am speaking in the last 1 hour, and you are able to probably appreciate a few things because it is a natural dialogue. And also the sentences I make, if you record it and try to transcribe it, or try to make sense out, quite a few, almost 80-90% or even more sentences are ill-formed, and they are also not grammatical. You see, but that is the one that the human being likes in a natural communication. And as I've already mentioned, the selective attention is a challenge which we human beings effortlessly do it. But and the practical speech is produced in many environments, noise, vibration, multi-speaker channel, and so on. We seem to capture the message very easily, but we don't know how to do it by an algorithm. And most important, you can be rest assured, the current technology will be replaced from in all part once we understand this. What is called the multimodal nature of communication. Speech communication. Speech is one way. You can also use it for language and so on. But anyway, speech is a much more general term used. Multimodal nature of speech communication is the one that challenges. See? And it cannot implement with any current, or even the way it is going, even future technology also. You see? And and the most interesting part here is, as a human being, the beauty of that is, when I am speaking, you are not, as I told you, capturing each sound or each word carefully and so on. You are capturing a pattern in that multimodal speech input. You see, the pattern in only human beings can do it. That requires another hour of talk by me on what do you mean by that pattern capturing and so on by the biological neural network. It's a totally different topic altogether. But you should understand that only human beings can do it. Machines can never do this. Can never do this. Question doesn't arise at all. And if you keep that human reference, it exposes the limitations of current methods and so on. That's why especially youngsters, don't get disheartened if you don't know, or if you are not able to catch up with something, or if you don't have so many GPUs, or if you don't get a job in Microsoft and Google. Don't worry about all of that. You see? they will change all the technology. What is important is to understand what is the real problem here. And so human reference exposes the limitation of current methods and so on. Another very interesting, this is my favorite topic, you may want to call it. We can spend any amount of time on this, but to appreciate the machine and a human being is processing and representation. Human being does processing and representation in that order, whereas a machine does representation and processing in that order. There is no way, no amount of technology development can ever bridge this gap. In fact, the more technology you use, the more gap wide that you find between these two. So this is where human being is distinguished from a human machine and so on. Processing and representation versus representation and processing and so on. And you may say, okay, all these are nice things that you said. What are the challenges? What is it? Don't simply go and apply another large language model, foundational model for Assamese language, this language. I think these are all wasteful time. You are wasting your time. And not only that, whatever little that you do, you are enriching somebody else's knowledge. You are not creating any knowledge. What is important, as I mentioned to you already, for want of a better name, I am using this word phonetic. Can you capture what is produced in the form of a symbolic form? You define your symbol, but in the form of a symbolic form. It's a so-called, I call it as a phonetic. If we can do that, I think majority we can never do that. Of course, I have been talking about it for 40, 50 years. And if you can really do that, notice that this is not simply a phoneme or something. Phoneme is only a concept, you see, and it is the linguistic unit of sound. In the continuous speech, phoneme doesn't exist at all. You see, and your approximation already destroys the information. And also, most important, a lot of people talk about speech translation from one language. This is absolute nonsense. You see, because somehow we are wasting our money and resources and our intellectual resources also in trying to build a translator in spoken form and so on. It's waste of time in a country like ours, because when you move from one place to another, even within the same state, within this one, the way people speak is so different. And all that you want is to convey a message. You are not interested in translating the speech word to word, sentence to sentence, and so on. Communication in a multilingual society is a challenge. How do you use part of the technology and most of your brains to accomplish that? That is more important rather than all your machine translation with this much accuracy, that much accuracy, this much naturalness. All these are wasteful efforts in some sense. And of course, another very interesting thing here is speaker verification for personal authenticity. See, again, we are being driven by the technology. You need 1,000 speakers, 10,000 speakers, hundreds of the lot of data from each speaker to train a model. All this is bogus. You see, you can just recognize a person by just a small gesture. Hello is enough. When you listen to a familiar voice in a mobile, you will say already, oh, how are you, Mr. So and so on, like that. So that is, and we are not able to exploit that speaker characteristics that are embedded in speech. It requires deep understanding and knowledge and processing of speech production, processing of speech signal to extract the speaker, not by this embedding mechanism that we have in the deep neural networks and so on. And another very interesting application that we have is, again, don't blindly use any of the current technology, then you are fake. I can guarantee that. You see, you have to think originally. And keyword or speaker spotting, because you have an audio file or something, and you want to detect the region where a particular person has spoken, or a particular word in that and so on, or a particular sentence and so on, phrase. It's a challenge. You see? It's a challenge in conversation speech. These are a few of the applications I listed, but there could be many, many more. You see? So finally, I just want to list the challenges, because the title of the talk is challenges, is patterns in high dimension, which human beings are able to do, and the patterns in speed that you capture in high dimension. How do you do that in a? That's one of the challenge, and information at multiple time frequency resolution that a human being does automatically. and natural process, which is speech communication is, and we don't know how to. No model, no, it is only selective attention, so on. And of course, this is it looks like a very odd example, but processing sounds of silence is a very important topic. We don't even know how to handle this and so on. And find the human reference. It's a If you take human reference and machine, no matter how sophisticated the machine is, how powerful it is, how many GPUs you use, and so on, and it is nothing. It is not comparable to BNN. Not that it is not useful. They do complementary tasks rather than one replacing the other, and so on. Because there is a definitely architectural mismatch between the architecture of a human way of doing a human biological neural network and the machine architecture. And so, and the from a speech point of view, instead of going into those numbers, hundreds of hours of speech and this language, that language, and so on, we need to focus more on speech, not hundreds of hours. Just try to understand a few minutes of speech. That is more than enough. You can really develop something which will replace all the technology. Since we don't have the technology, people are thriving right now. You see? And finally, in conclusion, since this is a topic on natural signal like speech, the beauty of natural signals is that the more you probe, the less you know. Thank you very much for your attention. I'll stop at this point. Organizers have to take over.
Oh, okay, sir. Am I audible, sir?
You are audible, but I have to do something? No.
No.
Okay.
Yeah.
But I can't see
I think,
you. Yeah.
yeah.
Now I
So,
can.
thank you for your very inspiring and very insightful talk. I think first of all, I'd like to ask Priyanku sir, if you have any questions or if you want to discuss anything.
So I have, yeah, Shishir, thank you so much. And then, I think I have many questions and many things to talk to sir. But maybe you just look at the others first, and we'll come back.
Okay.
And then
Okay,
if you don't have any questions, then of course I have I have written down all those.
Yeah.
So as a speech student, we have maybe a huge amount of questions to ask, sir, some fundamental questions too. Maybe we'll check the YouTube chat first, then as Priyanku sir mentioned. So Sankalp Jadam, he asked one question in YouTube chat. Is there any app where we can translate the Assamese to Hindi or English for easy accessibility? I think maybe I can answer that. So for Assamese to English, for speech translation, I think that in the open source, I think you can get from AI for Bharat something. Maybe sir, you can also give answer if anyone can want to develop what should be the plan, something like that.
Yeah, I think you are not directly speaking into the mic, so some words are missing, but I get the message. So what you are saying is some translation, is no?
Translation.
Yeah.
Translation.
You see, of course, a lot of effort is going on. Everybody is claiming a lot of things and so on. But if you ask me, with our kind of in India, with our resources, and we have a lot of intellectual resource, I think that is what you should use, not these machine resources and so on. It is useless because you can never compete with them, and also that is not the model. The current models are not the models to use for these things. You see, and translation, as I told you, is not a translation of sentence or word or something. Message communication. message communication, because we don't have a language, we don't have a English or something, we don't have India. In India, we use the 3-4 languages mixed up in a casual conversation. And you can't ask somebody to speak a sentence properly for your translator to work very well. So please remember that is the direction in which we have to go, rather than following what somebody else, what Google is doing. They may do something and they may sell the product and so on, and again they will send the next version and so on. Don't let us not waste time on such things.
Thank you, sir. So next question from Kumar Kostav. So that is actually my question also, whatever Kostav asked. Now his question is, if machines were somehow able to process speech directly rather than speech signal processing, what implications would this have for the design of speech-based AI systems?
I think your voice is breaking a little bit. Can you repeat once again?
Okay, sir. Am I audible, sir?
You're audible, but some sounds are missing. Important sounds.
Okay. So like the question is, if machines were somehow able to process speech signal directly, not speech signal actually, speech directly, rather than speech signal processing, what implications would
okay,
this
I
have?
got it.
Yes.
There is no way machines can process speech. Machines that you understand currently, as we understand currently, is a current computer machine, and there's no way it can process the speech directly. It has to be in the form of a signal, the first step, and there itself you lost. You see. Okay. So I think it is obvious that, as I think I mentioned already, between speech processing and speech signal processing, machines can do only speech signal processing. And for that, to do that processing, you need not just the signal, but all the extra knowledge that you use, which we don't know what it is.
Okay. So extra knowledge means like, for example, when I speak to you, so I have everything, maybe like how you speak and what other some prior knowledge
I'm
I
not
have.
talking about it. The extra knowledge about, although that is important, but more than that, the extra knowledge is that I should know English, for example.
Okay.
Or I should have the background of speech processing or something like that. Because if you bring a history person here or some other person here to listen to this, he will not be able to understand what you are saying. You see?
Okay.
So that is what I meant, all the background and so on. And we can't articulate and clearly say this is the background I am using.
Okay. So you are mainly talking about from the listener point of view.
Exactly.
Okay.
Yes.
Okay. Got it. So then, like, this perception thing is maybe like the important part. Perception thing.
No, again, I must. It's a very, very important question you have asked. Perception-based processing should never be done.
Okay.
I'll tell you why. What I'm meaning that is, you have a signal. Try to extract the production-based information first, and then try to use whatever additional first to capture the information. And then in a perception, some sounds may be useful, some sounds may not be useful. Directly you make perception-based analysis. If you ask me, although I'm in the minority in the scientific community, perception-based analysis of speech is wrong. You see, you miss a lot of useful information. That production-based information is important. You see.
Okay, sir.
And also that is realistic.
Okay. I think Kostav answer got answered. Then Lata Sudri ma'am asked, what is your take on LLMs versus knowledge graphs on text mining?
Okay. I think first of all, LM is good, but we should never get into that. It is not our domain at all. I see, because the point I am trying to say here is, It is based on large data-driven, huge computing resources to get something. And if it is not your ideas, first of all. And by doing any small thing, you are enriching somebody's ideas. Nobody will give credit for what you are doing. You see, you are wasting your intellectual resources on that. And it is not that there are no problems. After all, 10 years ago, you didn't talk about LLM. Why are you talking about it? And just as LLM came now, it will also go away after a few years. 100% guaranteed. There's no question about it. You see?
Okay.
So, and unlike many other countries, in India, we are fortunate to have a lot of intellectual potential. You see, many scientists are there, both in numbers and also intellect, and we can do wonders. But not by blindly following somebody. You see, no matter what, they use 1,000 GPUs, you will use 10 GPUs. How can you compare? And they use 1,000 hours of speech, you use 10 hours of speech. How can you compare? And all these so-called foundation models and so on, they're all, somebody is trying to market it rather than any content in it. And most of the time, we don't know what they're doing, as I told you. You see?
Okay.
Okay.
Sir, we don't have any other questions in the chat. I have, sir, two questions.
Yeah.
One questions maybe a bit maybe more philosophical kind of generally when we talk about TTR system, so we talk about naturalness of the speech signal. So we try to see like whether this speech is natural or not. Whatever we got synthesized. So my question is like, what is the significance of naturalness in speech, and how to actually quantify that? Like, how do we define the? Yeah.
You cannot quantify. It's a good question. The answer is very simple.
Okay.
You cannot quantify because naturalness and these are all qualitative terms. You see, and you can, in fact, you can never model them also because of that. And if you cannot, and you say some speech is natural, it is meaningless. You see, you are interpreting that it is natural. If you take to really to an expert phonetician or somebody, he says, no, this is bad. You know.
Okay.
So only it depends on who is listening and how much you are tolerating. All the see, if you are saying it is good because you are substituting the good part of it from your brain, not that it is there in the synthesis. No synthesis can ever be done, period.
Okay. Okay.
When I say in terms of naturalness, no, it can never be done. See, a lot of us don't know if the beauty of speech signal is it captures the fine variations of my production, which is so natural. Even a short gesture, when I say like this, you are already capturing me, my voice and my attitude. You see, and we can't articulate what is it that you are capturing. That is the beauty of the speech signal and speech production.
Okay.
You see.
Sir, another question, as you mentioned, machine can't able to like in future also maybe like it will not able to understand the way we understand speech. Okay, so one reason may be that because we are doing some kind of discretization and so much of information loss is there. Now, for example, just a hypothetical question, the way we consume speech, maybe it is a very redundant signal, lots of information are present. So the way we human perceive speech or like take the speech, so if somehow machine can able to take the speech, that raw information directly, will there be any chance or will there be any
The answer
possibilities?
is no.
Yeah.
No.
Okay.
Because again, to do all that processing extraction, machine has to have that knowledge. And you have to give that knowledge. And you don't know what that knowledge is to give.
Understand.
You see, I have, why I am able to hear few of these things a little confidently were 45, 50 years ago, I worked at CMU where they were injecting this knowledge into the speech to build speech. Then I could understand how they were struggling to do that and so on. In fact, that book is really good, although it is 50 years old. Vian Lee and Jane Chu. I am sure some of you can get a copy of that and have a look at it. It's a wonderful book.
Okay, so I will get that book and then maybe we'll share with the audience.
I think you should do that. Yeah.
Sir, my last question. After that, Priyanku sir has few questions. Sir, like when I talk about three things, for example, as you mentioned, like time, frequency, and phase. So we have some kind of back understanding or like some kind of visualization of time. Like what is time, for example, in terms of speech, like sequence, like from one event to another event, or how temporally speech is going on. In case of frequency, maybe also we have some kind of understanding.
In the case of?
In case of frequency, sir, we have some kind of understanding.
Good question. You see, I didn't want to delve into that, but frequency doesn't exist.
Yes, sir. So my
only
question
time
is,
exists.
okay.
Frequency, even as a concept, doesn't exist. We are only talking about frequency. In fact, that was the first question I ask in my regular classes I take. So in speech signal processing, first class, all of them went through signal processing courses. I asked them what is frequency.
Okay.
And I don't think they understand at all. And they give some silly thing, sinusoid, they'll say. Sinusoid doesn't exist. You see? No, a lot of interesting things are there. You see? Time only exists. The rest of them don't exist. We are loosely using those words. That is where the signal processing fails.
Okay. Sir, like how we can visualize phase? Because phase, yeah.
Good question. It is very difficult, I agree. Recently, I have given a 9-hour course, my project Master Murthy at IEEE ICAST in April this year. And that was phase processing of speech signals. And so if you want, it is about 9-hour lecture tutorial. But and I explained, it took about 3 years for me to collect all that flow. And if you are interested, I can send you a copy of. We have written a draft article. I have not published yet, but I can send you the draft if you want.
So kindly, you can send us. It will be like
you send me a mail, then I will know that I have to send.
Okay, sir.
Right.
Okay. Thank you.
That talks about phase. The title is phase processing of speech signals because 99% of the people who talk about phase in speech, they don't understand what phase is.
Okay.
Guaranteed. You see, there's no. I'm not exaggerating. Okay. Maybe including me. You see, I'm not saying that I know. You see, because just as frequency, phase also is not defined.
Okay.
It came as a process of computation rather than any. But having said that, you can, with some algorithms, we can process the phase and extract information. That's what I have presented in that course. And also a few papers which I have written recently, about a year back. You can refer to that. Anyway, that write-up gives the reference also.
Okay, sir. Very sir, I think what we can do, sir, you can stop sharing, then you can view Priyanku sir and all of us very clearly. So if you stop sharing the screen.
No, brother, Priyanku has a question.
Yeah, you can. I think you can view. Priyanku sir, I think you can ask.
Yes. Sir, thank you so much for such a detailed talk. I mean, it's so thought-provoking, needless to say. Sir, there are many questions coming to mind, and these are mostly like comments, and maybe we'd like. I mean, I'm hoping we'll get some responses. So, firstly, sir, when you're talking about this variation in human speech, we all understand, sir, that even if we speak language X, can you hear me? Is it okay? My voice is.
Your voice is clear. Yeah.
Okay. Even if we speak a language, a particular language, depending on the group with which we interact, our, again, like, all the acoustic characteristics will be very different. So the one question is that how much can we go on modeling this, right? That is one point that I want to raise. And then I think, like, in all these cases, what Shishir has also asked, that trying to achieve like human-like accuracy should not be probably the goal. Trying to achieve the functional, what is the function of that particular system that you are building? Trying to achieve the function, of the system in to a better, to an acceptable level is what should be the goal, and that will, I think, keep the scientific spirit and the engineering spirit both hand in hand. So I would like to have your
Thank you.
opinion
Yeah.
on that.
Unfortunately, you are speaking my mind. First thing.
Yeah,
You see,
yeah,
no, what you say is exactly true. In
yeah,
fact, in all these technology applications in a practical uh, situations, nobody wants a perfect translation. Nobody wants, they just want a hint so that they can proceed further. In fact, that should be the goal, not the number of word error rates or some error rates or human evaluations. All these are wrong things, you see. Just go to a new place, for example, where the language you don't know, etc. You few gestures and a few signs or some sounds you capture, you can communicate. You see,
mm,
that is the
right,
beauty of this. And your system that you develop should also be like that,
right,
rather than saying that it is perfect, accurate, it is high quality, mine is better than yours, put some number. These are all, fortunately, build a system like that, it will never be used.
right, mm,
I think you somehow you articulated my my mind clearly. You
right.
see.
So another point I just wanted to mention here, sir, that about this data that we
Mm.
have been talking about data, but the data, sir, when we are training something system with a data, then that also has our own selection bias. What kind of data are we feeding? We are feeding only what we have filtered. That is what we are feeding. But the system, when it's ready, it also encounters lots of error that people produce in their speech or in the text, etc. As human beings, even if I say something wrong, completely ungrammatical sentence, completely unheard of words, or something that you cannot hear now, you can still process it, right? So that, I think, that whole idea of providing this data, like giving more and more data to the system, and also manually feeding data itself is actually introducing some sort of selection bias in the data itself, and which I think is not going to work long term. So
You
I
see,
would like to have your
no,
opinion on
you
that.
are perfectly right, and also, uh, unfortunately, you are talking about data driven models only in the last 5-10 years. You see,
Right.
what after all, you are already a professor for so many years and doing research. Why didn't you talk about data driven 20 years ago? The
Right.
fact of the matter is that is the right way to do.
Mm, mm,
This is not the right way to do. We human beings don't do any data driven processing.
mhm, mhm.
Period. You see,
Right.
I think there is a fundamental. In fact, we in India especially, as because of the intellectual environment that we have, we can do wonders. I can do all that. See, if we can provide an alternative where, for want of a better name, I use the
Mm,
pattern that to capture and from a data that is available, not in large amount, and then give that as the input, the models complexity will come down by several orders of magnitude. Instead of 1
right.
billion parameters, all that you know need to know is only 1,000 parameters.
Right.
And instead of thousands of hours of speech, all that you need only 1 minute of speech. And true, it may not produce your 20% word error rate or something. I don't care.
Mm,
I don't care whether it is 30% for I am not even counting word error rate. I am only
mm,
interested in knowing whether the message is conveyed or not.
yeah. Right.
You see, most of
Mm,
the time the acceptance depends on the context.
right. Mhm,
You see, in a context, you want to buy something or you want to go somewhere or you all that you need, okay, bus timing or something or some distance. That's all you go. You move forward.
mm, mm, mm,
It is not that you need to get entire message.
right.
That is the kind of a goal we should set for all the systems that we develop.
Mm, mm, mm,
Which nobody, you can be rest assured, the data-driven companies will never do that. because
Right.
their business will go out of they go out of business.
Okay, sir, thank you so much. I have many questions, but in the interest of time,
Yeah.
I'm sure I'll meet you
No,
very
we
soon
can talk
somewhere.
separately also, definitely. Yeah.
Right, right, right,
Yeah.
right.
I
Thank
wish
you,
I
thank you
could
so
come
much.
there, but these
Uh-huh.
days I have my health problems. I am not able to move much.
Right. Yeah.
But anyway, we'll discuss again. Right.
Sure. Okay, thank you. Over to the organizers.
Yeah.
Thank you, sir. Actually, Postov has one follow-up question, sir. Maybe I can read it out, sir.
Huh.
So the question is, nowadays, a lot of companies are trying to develop models capable of detecting mental health conditions using speech. Is speech the best modality for a such task? So whether speech is like better modality for the mental health prediction, mental health condition prediction.
Because I am not good at answering that question, but speech and many other things also, which conveys person's mental state, of course, definitely. But I am not competent to answer that question. See, uh,
Okay.
see, the speech has a lot of information, but the point here is, as I told you, in fact, when you lift a telephone, the other side says, "Hello," then you immediately will ask, "Are you not well?" Like that. You see, so there is a lot of finer thing there, but it just I am not in that field to comment on it. You see.
Okay.
Okay.
I think, sir, we don't have any questions. I can, yeah. Yeah, so sir, we don't have any questions. So
Okay.
the last question from my side is like, for example, if one student who want to start his career as a speech signal processing or speech technology researcher, so what will be your advice? So assume
I
like
think
that.
you should, if you want to enter into this area, you must understand speech signal processing as a course, clearly understanding plus and minus points of that. That's exactly what I tried to convey in this talk. You see, I think even if you don't directly use any of these, but you must have a background understanding of this. Okay.
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 Thank you, sir.
Okay.
So I think with this we are going to
Okay.
the last part of our session. Sir, like it is very insightful, inspirational, and very interesting this session. And we also like as a from a speech technology, speech science background student. So we learned a lot from this, and even I feel like our audience also learned a lot from this session. And it will be what I feel. I spoke to Priyanku sir and our team members also. So this talk, I think, can be a starting point of who want to enter speech signal processing or speech technology areas. So that's what we feel.
Okay. Thank
Okay.
you.
So with this, I think we can we want to stop and we want to close our session. First of all, sir, I'd like to stop my streaming. Then Sasank, you can stop your